Hello tech enthusiasts and curious minds. Welcome to another exciting episode on Fix Flare Tech. Today we're going to unravel the mystery of a component that's omnipresent in electronic circuits, radios and televisions, the inductor. Akin to a backstage superstar, it plays a crucial role yet remains largely unnoticed. We'll delve into what makes inductors tick, explore their various types, and understand their indispensable role in electronics. So buckle up as we dive into the fascinating world of inductors. Our host for today, MQ Joshi, has a knack for breaking down complex concepts into simple, understandable chunks. Now, on to the workings of inductors. Inductors, in essence, are a type of electrical component used in circuits. Picture them as a little energy storage unit. When an electric current is introduced, the inductor stores energy in the form of a magnetic field. It's as if the inductor is saying, "Wait, let's hold on to this energy for a bit." But here's where things get interesting. If there's any change in the current flowing through the inductor, it reacts. It's like a vigilant guard, always on the lookout for changes. When it senses a change, it springs into action and generates a voltage. The inductor essentially opposes any change in current, whether it's an increase or decrease. This might sound like a lot of work for such a small component, but this is precisely what makes inductors so vital in many electronic circuits. They ensure that the current flowing through the circuit doesn't change abruptly, providing a sort of cushion against sudden changes. And just like that, the inductor takes on the role of a silent yet crucial protector in the world of electronic circuits. It's fascinating, isn't it? How such a small component can have such a big impact. Let's move on to explore the types of inductors. Now that you have a basic understanding of how an inductor works, it's time to familiarize ourselves with the different types of inductors. First off, we have air core inductors. As the name suggests, these inductors do not use a magnetic core. They're simply coils of wire. Though they may seem simple, their lack of a magnetic core gives them the advantage of being immune to saturation and the undesirable effects of hysteresis. This makes them ideal for high-frequency applications, such as radio tuning circuits. Next up, we have iron core inductors. Unlike their air core counterparts, these inductors feature an iron core. This core increases the inductor's overall inductance, allowing it to store more energy. You'll typically find these in power supply circuits where high inductance is key. Finally, we have ferrite core inductors. These inductors use a ferrite core, a type of ceramic material that's highly magnetic. Ferrite cores are great for reducing high-frequency noise, and you'll often see them in electronics like televisions and computers, where they help keep signals clean and clear. Each of these inductors has its own strengths and weaknesses, and their use will depend on the specific needs of the circuit. But no matter the type, the principle remains the same. Inductors store energy in a magnetic field, playing a vital role in the world of electronics. And there you have it, a quick tour of the different types of inductors. And with that, we've covered the basics of inductors. We've journeyed through the fascinating world of these electronic components, understanding their function, discovering how they work, and exploring their various types. It's clear that inductors play a pivotal role in electronic circuits, influencing the way our tech operates. Thank you for joining us on this enlightening journey. If you found this video helpful, don't forget to subscribe to Fix Flare Tech for more tech insights. Until next time, keep exploring, keep learning,